Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, we'll be looking at trends associated with electrons. So the electron affinity is based off the amount of energy that's released when a neutral atom gains an electron. Okay, and so as I take on this electron, I'm going to be releasing some energy associated with that process. That release is typically defined as an exothermic process. A minus sign would be assigned to it. But occasionally you could have some that fall into this endothermic category, specifically for those things that don't necessarily want to gain electrons. And so the more energy that's released, the larger the electron affinity of an atom would be. And so if we think about, well, who likes to gain electrons? Well, we know that our nonmetals tend to gain electrons. So you would have that increase in energy that's released going across the periodic table. And as we go up the periodic table, you'll have a similar increase. Again, it's a lot easier to gain in those things that are found closer to the nucleus. And so our overall trend is that alkali metals have that decreasing going down the column. But again, I like to think about it in terms of increase. And so you would have an increase up the table, and it's going to increase across the period. And so again, there are some irregularities that do exist, but in general comparison, you're going to be following that trend. And again, there are numbers associated with exact electron affinities. However, I would be more so focused on understanding and remembering what the trend is versus the exact numbers. Now, the last property that we're going to discuss is associated with metals and how metallic they are. How much are they behaving like an ideal metal? So let's just first revisit what metals are and what they do. And so metals compared to nonmetals are malleable and ductile. So malleable means that they can be pounded into flat sheets, and ductile means they can be drawn into very thin wires. When we think about the metals that we've seen, they tend to be shiny and they reflect light. They have the ability to conduct heat and electricity. And what we really care about is that they tend to form cations in solution, and that's because they're losing electrons, which means they're oxidized. Our nonmetals have exact opposite properties. They're brittle, which means they can't be pounded into flat sheets, or ductile, drawn into these thin wires. They're dull and non-reflective. They're insulators rather than being conductors, and they tend to gain electrons or become anions in these reactions, or they're reduced in that process. So with the metallic character, we're basically looking at how close an element behaves similar to those ideal properties that we just showed for you. The more malleable, the more ductile, the better conductors, how easily are they oxidized? And so this trend, well, think about where your metals are. The trend is going to increase down the periodic table, and it's going to increase towards the left of towards where the metals are located on your periodic table. And again, you would just be looking to compare one versus the other based off of where it's found on the periodic table. And so you can see here some common things. And the reason I'm showing you these arrows myself is because sometimes the arrows that are in the pictures are swapping if they mean increase or decrease. So for me, it's a lot easier just to know what is increasing, and then by default, I know it's decreasing. But you can see as you get closer to where the metals reside on the periodic table, the more likely it'll observe those typical metallic properties. Okay, and so here we go. We can see again where our metals and nonmetals are found on the periodic table. All right, and so we can again do these comparisons where we're able to pick which one would be more metallic based off of where it's found on the periodic table. And so if we were comparing SN versus TE, SN is further to the left, and so we would say it has a higher metallic character. Between phosphorus and SB, SB is further down, and so we would expect it to have a higher metallic character. Between GE and IN is further down and to the left, and so it would have the higher metallic character. And between sulfur and bromine, we could not declare a winner because they have opposing trends. So last but not least for this chapter, we're going to pick out of this pair who has the more metallic element. So between magnesium and aluminum, magnesium is further to the left, so it would be more metallic. Between Si and Sn, Sn is further down, and so it would be more metallic. Between bromine and Te, tellurium is further down and to the left. So we would select that. And between selenium and iodine, we would say that they're opposing trends. So we can't pick one or the other. I hope this video helped you guys understand electron affinity and metallic character. Make sure you guys like, comment, and subscribe, and come back for more videos. I'll see you guys later. Have a great day.